Okay, good morning one more time, and let's continue our practice. So let me show you my screen. Okay, let me one more time do it. So the last one was f of x is e to power of x. Now let's consider the next example and use the Matlab command plot to graphically represent this function e to power of minus x squared. Okay, we will begin with the the command linspace. Yeah, let me clear all. So x is lin space now. So it was from minus pi till pi here. Let's do it. Minus pi and pi. And then let's do just minus pi and pi. It takes automatically 100 values. values. So now let's continue. And here, let's write the function now. Y equals to, how to give e to power of x as x of x. Now, but in this case, this is not just e to power of x. Here we have e to power of minus x squared. So how to give this function now? It is now minus x, and the squared will give not only with power, with point power, dot power, because of this is vector. Here we have 100 vectors, and we need to compute the values in these 100 vectors. It's not just power, it is power, vector power. That's why we will put dot power here. Is it clear?
Yes, it's clear.
For example, first time it takes the value close to minus pi, and then the next value, then the next value. And for each values, it will compute the value of y. Okay, now let's continue and graph the figure. So plot x, y, and I said if you want to black color, we will put just k here. K, and then line widths, for example, 2. So let's check it. You can see the graph of this function now. Okay, now let's show this example with linspace of now not arithmetical 100. Let's consider 10 points. You can see here you cannot get the correct graph because of the less number of points. Is it clear why we need give more points?
Yes.
Yes.
So for 10 points, we cannot get the correct one. Okay, you can do it now on your computer also. Okay, sorry, let's continue. So now this is just plot of this function. So if we want to put here title, yeah, this is not good function. This is not correct function. Let's do it from the beginning. So now let's do title. So now look here. There is difference between them. X minus x squared, just like this now. Why? Because this is just title. So here it will be just x to power of 2. So that's there is no necessity to put here dot. Is it clear? This is just title.
Yes, yes, it's clear.
Let's show it. Just x minus x squared. Okay, now let's continue and move to the next function. Sine x over x from 0 till 4 pi. Here 0 is not included because of the denominator we have x. It's impossible, yeah, to divide 0. Okay, now how to give this function? Again, we will use this known command. So linspace, now here we have from 0. So however, 0 is not included, we can choose here 0.0001, for example. So it means this is not 0. Beginning from this point. And here 4 pi, 4 times pi. Now, and now we have function sine x over x, yeah? So y equals to sine x. Now again, what point division we have? Not just division, point division. Because of, again, they are vectors. X is vector here, vector division. So now plot, and for example, color green. Let's check it. You can see the graph of this function. Is it clear?
Yes, clear. So, Professor, we can't write that it starts from 0. We always should just write 0.1, or we have
any number. For example, you can write here 0.1 also.
Okay.
But if you write 1 here, let's check it. If you write here 0, I mean not 1, 0, just 0, yeah. From 0 till 4 pi, for example, yeah. So, and your function and your graph, they are same.
Not error. Yep, I understand.
Yeah, not error. Because of automatically, this is impossible to take the value 0. So take the next value here. But let's check what will be the, I mean, here, for example, where is our 0? So let's do like this. Let's show the result of sine x over x. None. You can see this is non-machine number. Is it clear?
Yes, it's clear.
because of if we divide by 0, the first, now here first element is 0. But if you divide by 0, this is not machine number. Okay, now let's draw the next function. X times sine 1 over x from 0 till 2. From 0 till 2. Here, let's give again 0.001, for example. And now function y is equals to x times x. Again, times here dot multiplication because of vector. And the sine 1 division, also the dot division, point division, like this. Yeah? X times sine 1 over x here. Okay, now plot. Let's do here. I want to get gray. What was the gray? I think it was GY. Let's check it. No, this is just yellow, yeah? So let's do one more time. Not GY, let's do it. Okay, blue just. So you can see the graph, it's not good here. So 100 points in this case is also not enough for good graph. You can see here we have straight lines. So that's why we will give more points in this case. Okay, for this, if we wrote this just length space, it takes automatically 100 points. Now let's give more points.
Can you give me 1 point?
Hmm?
Can you give me 1 point?
9?
Million.
New N?
Million.
Ah, yes, of course, million, yeah. We can do it. This is 100,000, 1 million, yeah? Now,
Yes.
now our function. It takes time.
Of course.
So you can see now good function. Can you see this intervals here? So this is now good function. Let's do not million, just 1,000 or 10,000. 10,000, let's do 10,000. So your function now. Is it clear?
Yes, it's clear.
Mm-hmm. So again, it depends on, of course, number of points. So now we'll move to the next part. So number 6, graphically represent the mathematical function f of x. X belongs to 0.1 till 100 using the Matlab commands plot and log. evaluate the function in sufficiently large numbers of points. Okay, let's begin with this part. Evaluate the function in sufficiently large numbers of points in the range of interest. So to write it, we have command x is linspace. So here we have 0.1 and 100. And let's give 100 thousands, for example. So values, points. And now let's write the function y is equals to, so square root we will give sqrt as the program language of programming. So sqrt. Now we have numerator and the point division denominator. Okay, so in numerator we have 100 times, here just times because this is just coefficient. And then 1 minus 0.01 x squared and squared. 1 minus 0.01, here also just multiplication, but when we squaring, it will be dot power 2. And here also we have dot power. However, this is vector now. And now plus 0.02 x squared plus 0.02 times x dot power squared. So now denominator here is 1 minus x squared and 1 plus 0.1 x squared. Okay, 1 minus x dot power squared, and let's open the brackets here. So close the brackets, squared, and plus 0.01 times x squared, semicolon. And now plot let's do right and answer here. So you can see here this graph, but sometimes it's not a good graph to work for us. In these cases, we can move to another scale. So we have also another command, log. So here we will represent graphically our function in logarithmic scale. Log, this is graph in logarithmic scale. Is it clear? For example, here, let's draw it with log. Instead of plot, we will write log. Is it clear? So let's check it now. So you can see now this kind of graph. Now, this is not in scale, previous scale. Here we have base 10. You can see this is not 1, 2, 3, 4. Here we have numbers with base 10. 10 to power minus 1, 10 to power 0. This is 1, and 10 to power 1. This is 10, etc. We do our scale bigger and larger. So now we have logarithmic scale, and our graph will be in this form. Is it clear? There is difference between log and plot. Log, it's in logarithmic scale. Any questions, please?
Why here we didn't write the name of function above?
Name?
Yes, I mean when we wrote the x in power of x in power of 2, it was on the top of the
Title,
graph.
yes, you mean title?
Yes, this is title. Exactly.
Yeah, we can do title here also. Just write, but but in this case, I think it's not necessary for us.
It will be very long.
Yeah, very long. Or you can write just y of x. Title, just y of x. This is just title here, and then it will be just y of x function. The main idea is here, create and build the graph of these functions. Okay, do you have any questions again? More questions, please? So plot and log we have. Okay, let's move to the next part. So, we have here, I think, no, so this is the, it's enough. Now, number 7. Write a Matlab function which evaluate the mathematical function. So now we will create and build new function in Matlab and save this function and work with this function. So in this case, this is a piecewise linear function here. Minus 2x when x less than 0, 0 when x 0, and 2x x greater than 0. We have different ways to build this kind of functions. Now we will start with the creating in Matlab function. How we will do it? So to create new function, you need to open here this Matlab, from Matlab menu, new script editor. So we will open this editor, and here we will type the function. How to type? Now we will do this one. So, okay, now let's write function here. You can see in blue it's automatically, yeah? F of x, fx now equal to, denote with any word, value, value of f of x. I did this example with previous groups, so I have ready one. Let denote with other one, f of x, like this. And now, enter. So we open our function. Now, so fx, x, this is a vector of points. F of x, this is output here. And now x is input, f of x is output. Now n, we give n. So n, this is length of x. Length of x. Length of x. Then fx now equals to zeros. in first cases, we consider only zeros, one row and n columns. So we open new vector. So and here the length of our x vector, and here f of x now from the beginning zeros, and the length here is n. And now evaluate f according to x. How? It will be, now we will open this cycle for I from 1 till n. It changed from 1 till n, and this is the greatest length. Now, if here we have now, so the first case is x less than 0, yeah? X I now less than 0. You can see here xi, it means this x first, x second, x third, etc. Your vectors. When it is less than 0, then fxi in this case, of course, fxi is equals to minus 2 times xi, because here minus 2x. You can see if x less than 0, it is minus 2x. Minus 2xi. Semicolon. Now, else if, second case, yeah? Else if xi equal to 0. Now, to write the condition, here we need to put double equality, 0. This is as Python. Then enter. And now, when it is 0, fxi also 0, yeah? Here just 0, just equality. And now, again, third case, else if, yes, else if, when x greater than 0, it is 2x. xi greater than 0, yes, fxi equals to 2 times xi, semicolon. So I think it's enough. And if and for. Yeah. And if and for. Just like this, okay. Now here we have save file and run. Can you find this button? Save file and run. We will save it. So save as. So val we have val f of x, yeah, in this form. Save to the your Matlab or Octave folder. Okay. Here we need to put here. So clear now. Now work with the graph. As first value, we will consider 1. Then f of x is value of this one, which we saved. Let's recall this function. So you can see when it is 1, the value will be 2. Why? Because of this is greater than 0. And it's put 2.2 times 1. It is 2. And then let's give this space of linear vectors to draw the function. Line space here from -1. They're written in the interval -1, 1. So -1, 1, and steps will be, for example, 10. And now, again, recall function fx, this wall. It should be same with your saved name, with your saved file.
Professor, how did you open command window after the function?
Just a second, I will show you. So now just plot, let's firstly plot fx. Continue this example and I will show you. So you can see the graph of this function now. So how to open the command window?
Yes, how after the function. Yeah, I'm here, so.
So bottom you have command window, open it.
No, I don't have.
You don't have?
Yeah.
So if you don't have open command window, do you have Octave here? This one menu, this menu?
Yes, I think, yeah, I have it. Yeah. So window.
Show command window.
Ah, yep, I understand. Thank you.
Or Control Shift and 0. Did you get your command window?
No, I don't have why. Window, show the command window, so no.
It's working.
No, okay, I will carry on.
Okay. How to open editor? So Artyom give question. So how to open editor? So editor we will open by this menu again. So here you have main Octave menu or main Matlab menu you have, and you will get from this one new script here you have new script, and this is menu editor. This one is saved one. Now you can work with the next new one also. Is it clear, Artyom?
So, Professor, can you show the command window or command window?
Okay.
What you wrote. Thank you.
So let me check the graph. Editor one more time. Sorry, so -2 xi and 2xi when it's greater. When it's 0, it is 0. Yeah, correct. So this is graph of our function now. Let's continue. So do you have any questions here? We can work, now we can work without editor also. How? Let me show how to work without editor. So we will write these commands in editor to the command window. If it's clear, let me clear all of them. So now let's do it in command window directly. X, it is len space from -1 till 1, for example. Yeah. Then now let's give again length and length of x, length of x, then fx, it's just zeros. Do same work in command window. And again, for I is from 1 till n, from 1 till n. So let's continue. Now, if xi less than 0, f of x equals f of xi, of course, f of xi equals to -2 times xi. Yes, so now if else if xi equal to 0, double equality again. So we have fx I equal to 0 again. And now else if xi greater than 0, fxi equal to 2 times xi. Yes, if it's greater than 0, yeah. And 2 times and. And now plot x, y. So let's show the plot now. Sorry, not y, fx, of course. Because our function fx now. So let's show the graph here. So you can see the graph when it has 100 values. So this is the graph of this function. You get the same one. Is it clear? So we can work in command window directly also. Which one is better? Students?
I think the second one, because the first one I couldn't just do it.
Okay.
Yes.
So, but we have the third way also. Let's do with the third way. Let me show. It's now. Let's clear and begin with the again x len space -1 till 1. So now let's give a function y. Look here. So in the first case, this is minus 2 times x. Yes, minus 2 times x. And look here, in one row, we get the answer. Minus 2x, then dot multiplication. Now we'll write interval here, x less than 0. Now, plus, we'll add the next one, x times 0, or 0 times x. Let's do first coefficient. 0 times x, then dot multiplication, next interval, x equals to 0. If x equals to 0, plus 2x dot multiplication. However, this is vector. Now, here we have x greater than 0. And now plot the graph. X, y. You can get the same one. Is it clear? This is a short way of getting this graph. This is not old graph. This is new graph. Let's do one more time. Plot x, y. Same.
I think it's the easiest way.
Yes, of course, this is the easiest way. And we can work with this function also. So here, for example, it's very hard to me right here. So x, for example, it is 2x or 2x squared when x, for example, greater than 1, and then x plus 4 when x between 0. Let's do here less than minus 1. Here we have now from minus 1 till x between 0 and for example x squared minus 4 minus 2 when x greater than, just do here 1 when x greater than 1. Do you understand me? So here we have less than, here 1, and this condition. So we have this kind of function. And let's do this one. In our case, this is just 0, yeah, here. But if it is not 0 and just interval here, what should we do in this case? Use this last method. So here we have x lim space. Now let's consider interval minus 5 and 5. Now, so y now equals to, I have to give this one, 2 times x dot power squared dot multiplication and then this first interval. So x less than 1, minus 1. Now plus next one, x plus 4, of course in brackets here, x plus 4 dot multiplication, next interval, so -1, like this, we need to do x greater than or equal -1, space, then symbol and x less than or equal 1. Is it clear? Now, plus, let's put here minus x squared. Let's put here minus x squared. So now minus, in brackets, minus x squared, minus x squared, and then -2. Yeah, we have -2, close the brackets, dot multiplication. So x greater than 1. And then semicolon. Now plot the graph. Plot x, y. And color, for example, red. You can see here the graph of this function in like this function. Is it clear, students?
So you just put this symbol of and, yes, and
yeah,
this
and
function go together.
Yes, this and this is this interval.
Okay, thanks.
X greater than -1 and less than 1. So this is it draws continuous function here, but it's not continuous function. You can see it's discontinuous function. Yeah, we have point of discontinuities. Here it should be jumps, but it draws continuous. And we will consider discontinuous functions also, how to draw it. Okay, any questions, please?
No, it's clear, actually.
No, yes, it's clear after this method.
Okay. So let's continue if it's clear. Let me clear all, let me close this one. Now we will move to the next exercise. Write a Matlab function in order to approximate the value of function e to power of x in the neighborhood of x is 0 by means of Taylor polynomial. So you know from mathematical analysis course how to expand this expansion of this Taylor polynomial. You can see here, and here degree n, and it is 0-centered. So this is Maclaurin, yeah, Maclaurin polynomial. Now stop the summation when the term xi over I factorial is less than a fixed tolerance, this tol. And we have the exact value of tol, it's equals to this number. And we need to round this function with x to equals to 1 and compute then relative error between e to power of x and this finite terms till tol. Is it clear with problem? So we need to expand e to power of x and then consider finite term till I over I x to x to power of I over I factorial. It should be less than fixed number. fixed number here is this tall is equal to this number. And we will continue till this number and we stop in this number. And then we have two sequences. We have sequence of e to power of x and we have new sequence. And then we will compare these two ones and find relative error with respect to exact function e to power of x. Is it clear now? Now we will consider how to write this polynomial, Taylor polynomial.
But teacher, e in power x will stay the same. Doesn't matter how much.
Yeah, of course.
The derivative we will take, but in this case, how can we stop this function, this polynomial?
No, we will stop x till xi over I factorial.
Okay, I see.
It should be less than tall. When it is less, when it is greater than tall, we will not take this term. We will continue terms till this tall. We have, instead of x, 1, and we compute this polynomial, okay? Putting 1 here. Now, let's do it. So we will do it again with editor. So let me close this. Okay, save. Now, let's write now new function for Taylor polynomial. So I have saved one. Let me open because we don't have much time. So let me open and the command. So open existing one. Which one? Yeah, this one, Taylor exp. So here we can see we denote a new function, vi. This is Taylor, we denoted it Taylor exp x tall. It depends on x and tall. So here the x is input and the v is output. So now tall, it is tolerance. I, this is degree of the polynomial. Term, this is just term of Taylor series. And now you can see here, beginning from 0, y, v 0, I also 0, and term is 1, first term. Now, if term greater than tall, we'll add v, this term, and I also increase it. So I will be I plus 1. And your term is now x to power I over factorial I. So we will stop here. And now let's run this file. So we run it. And now let's work with the command window. So let's give the first value, x is 1. Then write here the value of tolerance. It was 1.0, e minus 10. In this form, you can also write minus 10. And now it means 10 to power minus 10. And now vi, your function. V in square brackets it was. Vi, close the square brackets, and Taylor exp x tall. Like this from the previous editor, yeah? They should be same. Look here. vi tall or x tall. They should be same. And now enter. So you can see here, v now is equals to 2.71, I is 40. So now it means we need to continue till 40th power. Yes? Do you understand me?
Why I got to 14?
This is after the computing. We have this ready file. It will be computed automatically now. Because we recall this function, vi. So it will be compared with tall here. Is it clear?
But what is tall?
Tall, this is this number. We have tall. Given number. So process will continue till this number. So and when it will be greater our tall, then it's stopper. I mean our term. When greater than tall, it's
yes, it's understandable now.
Hmm?
It's understandable now, I say.
So, and now you can see the value of v. The value of v, this is just the when you put 1, it is equals to this one. And we need to continue till 40. Here you can see in editor, xi factorial I, yes? So I, it's 40. So we need to continue this till the term x 40's power over 40 factorial. Okay, so now let's continue and find relative error. So let's denote it by ERR or just ER. It doesn't matter. So now how to find relative error? Do you remember from lecture? It was absolute value of exact function minus new function over
right over exact function.
Yeah, absolute value of exact function. Yeah. So in this case, ABC. Absolute value will give ABC, yes. ABC, it was, for example, in this case, y. Our function is now y. Y minus x, yes, over ABC, absolute value of x. Is it clear? Now let's compute it. So in this situation, error is equals to this number. So we have this kind of error. Is it clear? Yeah, we worked with editor. We created new function. And then we did this error. We find this error. Using this new function. Please give your questions.
Is it normal that our error is close to tall number?
It can be, yes.
But in this case, I think error is too big if it is close to.
No, it's not close. No, it's not close to tall, because a tall is 10 to power minus 10. Here we have 10 to power minus 12.
But just 100 times smaller, it is not so big.
Yeah,
difference.
This is 100 times smaller than tall. In this case, this is equals to this one, yeah. So error, it depends on your function also. For this function, for exponent, for e to power of x, the error equals to this number.
But if it was 1 from 100, it is, I think, big enough error.
Yeah.
1%.
Yes. So again, it depends on function. It depends on values, of course. So when it is smaller, it is good. Okay, any other questions, please? So with this example, we finish it, our exercise session 0, and the next time we will begin exercise session 1.
Okay, thank you.
If you don't have any questions, we'll finish today's lesson and we'll continue the next time. Thank you for attention.
Do we have all the answers on the group?
No, we have only answers of exercise session 0.
Yep. I mean about it. So we have, yep.
Yeah, exercise session 0 we have. And we have also in my YouTube channel, we do lectures of these lessons. Okay.
Okay, Professor.
So I put lectures. I give the link I sent the link to the group. So here we have lectures, lecture number 4 and lecture number 5. After the starting online mode. So, and then practice of also. I put just 2 practice 2 and practice 3. They are same. That's why I put just only 1 practice. Okay, 2 and 3 just. You can find these lectures and practice. Okay, thank you for attention.
Okay, Professor. Goodbye.
See you. Goodbye, Artyom.